Good afternoon. It gives me great pleasure to welcome all of you to join today's Innovation and Leadership in Engineering Forum. My name is Christopher Chao. I'm the Dean of Engineering at Hong Kong U. I am also one of the alumni, and I'm very honored to be the moderator of today's forum. I graduated in the 80s from Mechanical Engineering Department, and today we have three distinguished speakers who are also alumni of Hong Kong U Engineering. Let me give you a brief introduction of these three speakers before I move on and let them introduce their talk and some of the wisdom that they would like to share with you. Nowadays engineers will not just sit back and observe. Instead, we make things happen and we make modern life possible. We would make use of our innovation, creativity, and professional knowledge to lead our society and also to make impact to our world. We are so happy to have Dr. Ada Poon, Mr. David Lee, and also Mr. Ka Leung Lee with us today. Unfortunately, Mr. David Lee still has not been able to get into the system due to some technical difficulty. We are now trying to get out of him, but we will not wait for him. We will start with Dr. Ada Poon and Mr. Ka Leung Lee first before we bring him back to all of you. Dr. Ada Poon received her BEng and MPhil degrees in electrical and electronic engineering, and also she got her Master of Science and PhD degree at UC Berkeley. She is currently the Associate Professor of Electrical Engineering at Stanford University. Upon graduation, she spent some time in the industry before going back to academia. She's now working in biomedical engineering related research. I understand that in her talk, she will also tell you more about what her background is. So I will not talk too much about Ada. I will let her brief you more about what she is doing. Mr. David Lee received the BBA in Information System and BEng in Software Engineering in 2003 and 2004. David is the co-founder and CEO of a Silicon Valley startup NEX team, which has developed a very famous AI-powered iPhone basketball app called Home Court that has been highlighted by Apple and backed up by NBA luminaries like Jeremy Lin, Mark Cuban, and Steve Nash. The app is being used by players and teams in 200 countries around the world, including NBA teams, Boston Celtics, Philadelphia 76ers, etc. So he also received a lot of newspaper attention about 1 year ago when we invited him to Hong Kong U. Mr. Ka Leung Lee received the BEng in Civil and Structural Engineering and Master of Science in Civil Engineering, also in 2003 and 2004. Respectively. He is now working as a project director with BEng-EEE Public BYTP since 2017, running very large-scale civil construction projects. To give you a few examples, that includes MPhil West Island Line, MPhil Stratton Central Link, tunnel boring machine section, DSD Inter-Reservoir Tunnel Scheme, and Central Kowloon Route Project. He joined Dragages Hong Kong Limited in 2000 as a Scheme A graduate engineer, gradually moving up his ladder. He is now a fellow of the Hong Kong Institution of Engineers, corporate member of Institution of Civil Engineers, and also the Institutions of Structural Engineers. He has progressed through senior engineer to construction manager and now to project management. So all of our speakers today were actually strict A students as they receive first class honors while studying bachelor degrees at Hong Kong U. I'll first invite each speaker to share their career success and development individually. A discussion section among all of us will then follow. Of course, we will spend some time on taking a few questions at the end from our participants, and you might drop the question in the chat box in Zoom. Without further ado, let's start the forum. May I invite Ada to share her insights with us. Ada, please.
Could you see my slides?
Yes.
Yep.
Okay, so I would like to give you a brief summary of my what I call is a random walk from when the time I at Hong Kong U to where I'm right now. So I did my undergraduate at BEng-EEE at University of Hong Kong. Afterwards, I went to Berkeley, UC Berkeley, to do my PhD study. My research is focused on information theory, which I would say that it is one of the most theoretical branch in electrical engineering. So what I want to say it is I was a theorist by training, and my thesis it is in the area of massive MIMO systems. What is it? So it is basically it is one of the basic fundamental technology that is included in 5G system right now. So I think I did my research too early. And then after my PhD, I went to Intel. As I mentioned, my training, I'm a theorist by training, but at Intel, I did silicon chip design. So it is totally different from what I did in my PhD. After a year at Intel, I kind of taste working in a big company. And I think working in a big company, it doesn't fit me well. So I quit Intel and did a startup together with my PhD advisor and my friends at Berkeley. We tried to develop the first commercial CMOS 60 gigahertz system. So what is CMOS 60 gigahertz system? It is a technology that will enable high data rate data transmission wirelessly. So it is now being part of the high data rate Wi-Fi, which is the L2.11ad. And also it is a key technology also in the 5G system in order to support high data rate transmission. Now, being the first to do the commercialization of a no-cost high data rate system, usually it will not success, and we are not the exception. Because we are the first one try to do it at a low cost rate more than 15 years ago. We were looking at what kind of application, what will be the market that we're targeting at. We target at the wireless HDMI, that is try to replace the cable, the cable that's connecting the set-top box to the high definition TV because it requires high data rate. We do pretty well. After a year, we do the fundraising. Our first round of funding, it is 18 million US dollars. So it was quite good at that time. But then at that time, I look at the cable at my home that is connecting my TV to the set-top box. I don't feel this is too troublesome to me. And therefore, I thought, I cannot convince myself that in my next 10 years, I'm just doing a cable replacement. This doesn't sound cool to me. And at the same time, I also, I've been working in startup for 1 year and Intel for another year. Making things cheaper and faster in consumer electronics space, it really didn't resonate with me. And therefore, with the encouragement from my PhD advisor, I decided to go back to academic, and then I joined the faculty at UIUC, University of Illinois at Urbana-Champaign. At that time, I decided to switch my research area from being a theorist to chip design, but to biomedical systems. After 2 years, I think I learned a lot in the biomedical systems, and I kind of know what I would like to do. But at that time, because of a family issue, I quit Urbana-Champaign and I moved back to the Bay Area to stay closer to my family. And then I need to do something, right? So I start another company. It is in 2008. And the company is trying to commercialize NFC, near field communication. So NFC right now, it is kind of quite popular technology that is in the cell phone. But at that time, it was not. So I thought NFC could be one of the applications that I was looking at. It is for counterfeit drug detection and also a new form of electronic payment. So Visa is just in the Bay Area, the Visa headquarters, so it's very convenient to talk to them. But unfortunately, it is in 2008 in September, I supposed to get the funding from venture capitalists to fund my company. But Lehman Brothers collapsed. So the whole economy collapsed. So, and I thought time is not with me. So a month later, I joined the faculty of Stanford. And in the past 12 years, I've been focusing on using electronics to treat diseases. So what do I mean by using electronics to treat diseases? So what we're trying to do is to build electronics that are really, really small, such that it could put very close to the nerve or the organ where I want it to moderate the biological activities. I want to talk to the language of our body or the neural system, which is the electrical signals. So electronic systems, one of the good things about it is it has very precise temporal and spatial resolution. So I can very precisely to talk to the nerve in its own language, which is the electrical signals. This is different from pharmaceutical approach where when we take the drugs, it acts globally through our body and it may produce side effect. But the electronic approach, it acts more locally and in a very precise timing. So it may provide an alternative to pharmaceutical approach or the chemical approach to modulate biological activities. And so in order to realize that, there's a lot of obstacles we need to solve, but I'm not going to go into the detail how to solve the obstacles to make the devices really small. But instead, I would like to give you an idea of how small is small. So this here shows is the devices that compare with a regular size of the rice. This is a pacemaker. This is a pacemaker that we put in the heart to maintain the heart pacing. We've already testing these devices in different animal models from rabbit to a pig model, and the project is done. The technology has been licensed to a few companies, and they are applying this to urinary incontinence, and also, which is very important for elderly, and also pain relief. In addition to do the cardio pacing, we also do something like for the neuroscience and try to do remote mind control. So here you will see that a peppercorn size of a stimulator, we implant it in the right motor cortex of the animal. And I was very amazed when we have a remote control to turn on the devices. The animal will stop its random movement, as you will see here. Because we implant it in the right motor cortex, so it will do the counterclockwise direction. So it will just move in a neat circle in the counterclockwise direction. Even though at this point, it doesn't want to move in that direction, but because we stimulate it, it forced to move in this direction. So this experiment is a little bit evil, but it also illustrates a different idea of a wireless mouse. So after, we feel that we are able to build devices that are very small, that is able to interface with organs and nerve. I go ahead and spend, this is in the time of 1915. I decided that I want to jump from just building a system, engineering systems, to a specific disease. So I want to treat diseases. I take a year off in between 2015 and 2016 to think about what kind of diseases that I would like to focus on. And I come up with 3 criteria. One, it is currently there's no drug to treat the disease. Second, it is drugs have side effects in most of the chemical, solutions. The third, it is drug is too expensive. So at the end, in 1 year of searching, I decided on working on a few problems. One, it is I'm trying to treat the diseases is in the early stage Alzheimer, where currently there's no drug to treat it. And I'm looking into, if a electronic approach is able to provide a solution. And second problem that we're working on, it is obesity. A lot of the anti-obesity drugs, they tend to cause a lot of problems, side effects to the cardiovascular system. And we are using the electronic approach to bypass this such that people can prevent obesity or even to treat the obesity without causing any problems to the cardiovascular system of the heart. The third one that we are focusing on, it is the diabetes. So we are trying to look at an electronic approach. It is to provide unlimited in situ supply of insulin and glucagon. That is the way we do it. It is try to also combining synthetic biology with engineering to architect a artificial pancreas, such that it will use our own cells to produce insulin and glucagon unlimitedly. And then the fourth one, it is the cancer. We focus, it is on brain tumor. So this, at the, to summarize my talk, I would like to show a photo that I like a lot. This is exactly try to illustrate what I'm doing. It is, I want to see if we could use electronics to provide an alternate way to treat diseases.
Wow.
It's 5 minutes, right?
Okay, thank you. This is amazing. I noticed that our second speaker, David Lee, just arrived. David, are you ready to give your briefing to us?
Absolutely. So first of all, so sorry about this. Like I mixed up my time zone as well. I thought that my talk would be at like 12 midnight here. Looks like I just completely screwed up. So first of all, like my sincere apologies for being late, and it's not my intention at all. I was in another meeting, like because I have like team in both Hong Kong and Cooper in West Coast in the Bay Area. That's why like I have half my meetings in US daytime and half my meeting at in nighttime. So I was thinking, oh wow, what's going on? And then thanks for Monica for calling me, and otherwise I will miss this important occasion. So like first of all, like really apologies for being late. All right. So just want to give introduction of like who I am and what I've been doing. I am entrepreneur. Like I build companies. This is my second startup now, and my first startup was founded when I was still a student in Hong Kong U. It's just kind of and we kind of keep following that path, and like now I'm doing my second one. So give you a little bit of like my background story of like how I from Hong Kong U like do my first startup, and then now I'm to what I'm doing now. So in my third year, and I was studying a double degree program in Hong Kong at that time. In my third year, SARS hit Hong Kong. It's 2003. And in that summer, I was supposed to do what they call industrial training, meaning that's like it's a glorified word of like internship. You could go and find internship. And it was SARS year that basically there's no internship around, and but like I don't even interested in doing internship in our company because I have an idea I want to build, and just want to take this special occasion, then like form a team and present a proposal to Hong Kong U that like I can form my own company and hire myself as intern, and a few of my other classmate as well as intern, and basically co-found the company and build the first project. Actually, the first client is also Hong Kong U. And one thing after another, my first startup, going from building event management software, building like something like a calendar software before Google Calendar, then to build online spreadsheet, and then that thing got acquired by Apple. Roughly 5 years later. So I graduated in 2004, and then like Apple acquired my company at 2008. And then I joined Apple for 8 years and built their, the entire suite of like iWork. If you use, Apple product, if you use 8 pages number Keynote, my team built the web apps for that, and bring in the basically collaboration feature into that suite as well. So this is what I have been doing for Apple, like, you know, create product that like spent like 3.5 years of my life just focusing on like building demos that to prove to Steve Jobs that like we can deliver Apple experience on a browser, which had not been something that he believed in. So like we managed to pull that off and like, you know, get one of the things that he finally approved before he passed away in 2014, I think. So, you know, we you know, shipped that, and you know, after a while that, you know, I think, you know, have experienced enough of Apple, and in 3 years ago I left Apple and founded a new company called Next Team, and this time basically really purely following our passion. I don't know, you know, some of you may know, some of you, a lot of you may probably not, that like I love basketball. Is the sports that I play when I'm young. Is the sports that I play when I, you know, and how I connect with my younger brother. They'll basically go and play pickup games like together at night, and it's a lot of fun. I'm not a good player, but I love the game. And you know, one night that you know, my wife dropped by and watched me play, and I cannot make a single shot. Then basically what inspired that, oh, can I get my phone to understand basketball? Can I get my phone to understand my shot, you know, and track my highlights? And then we start building, like, you know, just like, you know, and cold call the coaches in the region, in the area, just like, you know, just, you know, get ourselves kind of connect to kind of basketball, and just, you know, totally starting from scratch. And again, one thing after another, you know, we create something that's interesting enough that like Apple put me on stage. You know, I spent 8 years. Yeah, I put multiple products on stage. You know, in my tenure in Apple, but like I have not go on stage myself. And you know, I don't, you know, just that, oh wow, Apple actually think this what we did is like interesting enough and put me on stage. And I went on stage with Steve Nash. If you know who Steve Nash is, he's a really, really great player and been advising us on how to build this thing. And then like NBA take notice, and NBA is our investor now. And together with like a bunch of like, you know, NBA players have invested in the company, and you know, we are you know, building you know, an app that can deeply understand what's in front of it. You know, tracking basketball shots and understanding dribble, you know, great drills that like help train kids on the, you know, body-eye coordination, and you know, start using by like, you know, again, millions of users. So you know, this is like my short story. I don't know whether I used my 5 minutes yet. I did not count, but like love to share more of like, you know, what I'm doing. But yeah, I just love building things, and you know, that just is a way of life for me. Just yeah, so love to share more when we get to that point.
Sure. Thank you very much, David, sharing your entrepreneurial experience with us. We'll get back to you later. The next speaker will be Ka Leung Lee. He is the only one among the 3 speakers today who is working in the you know, traditional professional engineering sector. But in fact, his career is also not so traditional. So perhaps we invite Ka Leung to share with us his experience.
Yep. Well, thank you very much. Can you all see the screen? Good.
Yes.
Good. So I'm not an entrepreneur, and I'm really fascinated by Ada's and David's experience. So I would like to share some elements in construction management, because I worked in the field of construction contracting, and up to now, like 20 years in the same company. Let's just say project management, it's my skill. So let's say there are like, if I select, there are like 7 elements. There are people, safety, technical, program planning, finance, innovation, and of course the central theme of leadership. So as a background, at the moment, I'm managing a construction project of a certain central Kowloon route, which is a vehicular highway tunnel from the Kaitak region to the Yamate region, and inside which our company is responsible for a 3-kilometer twin tunnel. Each of the tunnel, they talk about 3 lanes, so they're pretty wide, pretty deep. Contract term is 6.2 billion. It's an NEC contract form, some 5 years. Us, we are directly contracting with the highway department. We have about a consultant company supervising us, and let's say working with us, we have consultant companies for various design. So that's another, let's say, 3D image of our tunnel. Basically, we have 3 attacking job sites, one in Homentin, Amate, and Korea, from which we enter into quite deep underground and then attack to create our tunnel. So we are basically using explosives. So this is a typical small section. I think this is the smallest section, some 7 meter high, 9 meter wide. We drill holes, we put in explosives, and then we time all these explosives into different delays, each differing by like a few milliseconds, and then we blast, and then we pull out the materials. So that's the background against which I show a few aspects. Well, first of all, project management, it's about people management. So it's like working with a lot of, let's say a few key departments. We have a department dealing with all the technical aspects, geotechnical design method, commercial, dealing with the clients, the main contract and contract under us, procurement. And then, of course, we have a big construction team inside which there are like hundreds of workers. They manage all the subcontract direct work, manage the tunnel boring machines, a lot of plants and equipment, surveying. How do we underground? How do we know where we are going underground? Survey is very important. Blasting technique. Of course, we have a bunch of department heads, safety, quality, environmental, document control, and then there's the department for the administration, cost control, and finance. So I guess the first point in summary is that as a team of project management, we are not necessarily, let's say, the expertise in each of these aspects, but we need to make sure that they are well close amongst these department heads, and in case there are some specific campaigns, specific topics, we need to create some specific, let's just say, committee and work task force in order to tackle individual problems. So the safety, the second aspect, it's really, actually this should have been the first one. It's about construction safety, because at the peak we are dealing with like 600 workers, operatives of different skills, exposing them to various degree of risk. So managing safety, it's really the primary concern. Of course, it's not really only about putting personal protection equipment. Indeed, about safety, the employer, we as employer, we have a general duty to provide a safe and healthy working environment for all of our workers. And this is only a high level obligation. So there needs to be in itself a safety management system with in itself a lot of individual elements. So if I pick a few of these elements, we have to issue a safety policy with clear measurable goals. We need to instill a safety culture so that people knows that the entire project management, they are on it. They put safety as the top priority, that each of them knows that there's the duty on their behalf, and also they have the right to say no. We as project management, we need to visit the site. We need to get in the ground to show some visible leadership. We need to put standard rules, special rules, etc. We need to devise some regular inspection to look at the processes, to look at the behaviors, etc. So this is big in itself. And we also need to get to the ground. So this is myself inside a hanging basket, which underneath, this is like 100-meter deep drop shaft. And the safety aspect is really on this lifeline here, which has an automatic clutch. So the idea is that as management, they are like like tens, hundreds of documents coming to your desk you need to sign, then you need to have a sense of, you need to have an instinct to detect which you need to dig deeper and to investigate personally in order to know what you sign up to are really providing the safety measures to your workers. So third aspect, we of course learn. This tunnel project in itself, it's involving like pulling out some 3 million tons of material from the underground. So there's a big part of planning and progress monitoring. This is just what I extracted from my university notes, all these goal setting, targets, application, updates, identify problem, replan because of the problem, and keeping track of the key performance index. That's the theory, but if you put into actual tools, these are the, let's say, day-to-day planning tools we have in front of us. So that's the, we will be planning basically the speed of the tunneling. As you can see, there are regions we can go faster, and there are regions because of very bad ground, will be going quite slow. So this is where we plan our major activities. Then we have various other planning tools in order to track the actual progress against the planning submission. We have all these zigzag lines regularly, weekly basis to see where we are behind. Plants and innovation. So we are dealing with a lot of machines here. We have like big tunnel boring machines. I understand Elon Musk is trying to put hands in there, smaller tunnel boring machine. We also constantly have to balance between sound established machinery versus innovation. And this is where in a recently completed project, we are trying out a kind of robotic arm for drilling. We also innovated a kind of bespoke system to install all these things. I would say they are not quite able to be scaled up because of all the specificity of individual projects, but the idea is the idea of innovation. It's let's say the underlying theme. Let's move on. I just show here one of the main interesting bits about large-scale projects that you get to arrange, manage huge machine. That's a front wheel loader. The bucket size is like 4 cubic meter. It's front wheel because you need really the main thrust of the motion to be close to the bucket in order to insert deep into the mud pile. We have a lot of logistical calculation, making sure that we can be pulling out 4,000 tons of material underground. So each of the operation, bucket size, traveling distance, number of machines needs to be well planned in order to cope, let's say, with the overall planning. Then there are also a lot of application of what we learned in school in Hong Kong University. This is talk about doing geological investigation underground, pulling all these coring samples in order to ascertain the nature conditions of the ground. So in fact, if we are hitting into very competent solid rock, there's no problem, because by then you punch a hole, the ground is going to be stable. But it's really these kind of, let's say, bad materials that we are very scared of, because if we are hitting into so-called fault zone, all these bad materials, they can collapse and underground water can run in and your tunnel will squeeze, collapse, so as the surface will settle. So one of the main, let's say, workflows is to ascertain along the tunnel or the situation and devise we need to do some ground treatments, etc. Then a lot of analysis, application, structural modeling, calculation of the ground settlement, calculation of the slip, let's say, surface of a certain slope. So we make use of a lot of BIM in order to better visualize our construction sequence. We prepare a lot of all these graphical, simple method statement for the workers and operatives to understand more. These are the design versus the actual. So this photo I'm showing here, it's the temporary work design which overhangs the basket which I hopped on just now. I show you, and I was really careful to check all these bolts to be correctly drilled, correctly grouted, because not only me myself like hanging there, but all the workers. So it's really serious business. A lot of BIM application for sequence, clash analysis, quantity, and 3D visualization. So I think I will probably stop here by showing one example of making use of BIM modeling in order to better visualize the sequence. Because we are talking about cramming a lot of activities inside a tight spot over a very short period of time. So if we don't use all these BIM modeling, it's really difficult to just look at a piece of paper and all these time chain H program. So that's the final slide. At the moment, in my project, this is the first time we created a dedicated innovation department. We are looking into a digital twin model. Maybe I can have some collaboration with David afterwards. The idea is that we have like hundreds of machines and also workers, whether we can create a digital twin of the entire construction real time. This is good stuff. This is a pair of stereo camera installed to the back of all these big machines so that we can detect people instantaneously and alert the driver if we're coming very close to them. Because in the mining business, it's very often to have serious or even fatal accidents around people crushed by heavy machines. I guess I ran out of my time, so that's probably it of my sharing. It's about construction management. Thank you, guys.
All right, thank you very much, Ka Leung. Now all three speakers already gave us a briefing. So let's move on to the discussion section. A couple of questions came up to my mind. I would like to throw them out, and then each of you can jump in and give us some of your advices or wisdoms. The topic today is about innovation and leadership. Why is innovation so important in today's career development, and is it a necessary part or a crucial element in going to leadership? Can you share with us some of your thinking? David, you want to?
Yep.
You want to go first?
Can you hear me?
Yes.
Oh, sorry.
Yes.
Yeah, I seems yeah, just unmuted. As a startup, like innovation basically is really the core, to it. We found a company and we wanted to create something that is different, that is better, and deliver new value to our users, take users to new places. My first startup did an online spreadsheet, and it's really, a few months before Google launched theirs. And then we have our, really interesting, competition with Google and try to see, what exactly, like how online spreadsheet is different, is better, and now it become a standard of like, we will expect, a spreadsheet, you can have multiple people working on it and have like, all these things update in real time. And it, from when we started, it become a standard, and it's also become a reason why like Apple want to, buy us, and really incorporate that technology into that suite of software. And like in my second startup is also that like, how we can create something. I remember when we first started, that the first thing we break through, wow, like AI was very new in mobile. And our first model basically 500 meg, and we basically start building it. It only works like in 2 hours a day. When the sun is right up there and you're outside, and then we don't have the noise of like your shadow, you don't have your reflection, and then we have something that works. And from there, we keep breaking through different kinds of like barriers and solving interesting problems to get to a place where now we can have something that like really understand like what you're doing in front of it, in front of the camera, right? And I cannot recount how many patterns I have already, maybe 5, maybe 10. But that's basically the process of like creating something new, and when you have something there, like it become a force to basically pull people and capital like towards you, and then you basically have something, have a company, have a product, and you have customers, you have partners, and that is basically the really kind of the gravity of a startup, and it's like how I can recruit the some of the best people, former Apple would leave Apple to join me, like leave like Google to join me, and that is what the core feel like when you build a startup. That's the innovation. What are you doing that is different, that's better, that's something that people want? And when you have that, then like good things start to happen. I would say that good things start to happen.
All right. Wonderful. So how about Ada? You have anything to share with us about innovation and leadership?
So I think innovation is the thing that might make us our life more fun, less boring. And also, I always tell my students, if you're not flexible, you don't innovate, you will be replaced by AI. Machine can replace you. So we have no choice. We have to innovate. And I can give you an example. Engineering education actually made us quite flexible and made us to innovate and connect us to different applications. Say, last night, I got a call from my former student. He already graduated a few years ago. He called me and said, Ada, I have an idea where I could detect COVID-19 on a chip, which is disposable, and I can mail to people. And then they could just put their saliva on that chip, and it's able to detect COVID-19, and it's disposable, very cheap, because it's a silicon-based solution. And then I said, okay. And I keep hearing his story, how he did it. And then now he gave me several reading that I need to go over to review them and then get back to him. And the reason why he talked to me is because he wants to look for funding to support that, right? So this is an example to show that with the engineering education, we are able to, we are more flexible, we can adapt, and at the same time, we can use our skill set to solve real life problem easily.
Very good. Ka Leung, you want to give us some advices?
Well, I really don't have much to offer. To be honest, I think in the construction field, the level of innovation is really pretty low as compared with what Ada and Dave have just shown in their respective field. But nevertheless, I guess some of our students are also aware that the government is pushing forward a so-called Construction 2.0 initiative, inside which there's a big push to adopt innovative solutions. So whilst what I want to say is that whilst we are behind, I still believe that it's important to always have innovative solutions kind of mindset, because this is the way to engage. This is the way to engage people to try to attack problems from their own initiative and from new angle. And that is the reason why even in our project we are trying to form a cycle, form a team just to deal with.
I think being behind is not necessarily a bad thing, because it also means you have a lot of rooms in front of you. You're able to apply innovative elements into the profession. You're able to bring your profession one level up and become a core pioneer in the development. This is exactly why I think we would like to stress the importance of innovation, so that you will one day become a very important leader in that particular discipline. So I have a few other questions that I'd like to ask, in fact, but I also noticed that we are receiving a lot of questions from the audience. In fact, some of these questions also overlap with some of those I'd like to ask. So I am now going directly to the Q&A section raised by the audience. This is a question for David Lee. What do you think about the prospect of having a startup in Hong Kong? Particularly, the economy is not good around this time. Do you want to give us some advice?
Sure. Yeah, I think from my experience, I founded my first startup when SARS hit Hong Kong. Whenever there's risk and whenever it's a bad time, there are also opportunities, right? And if I leave the university, if I graduate at a time where like the economy is so good, I would not be able to manage to recruit some of the best and brightest and the smartest people I know who are just my classmates. And it's because that we have a really bad time and there's not a lot of opportunities out there. I managed to form a team with like some of the brightest people I've ever known. And who just happens to be, in Hong Kong U and studying with me, just next to me, just my classmates. And we're still working together to this date. So like, don't underestimate what the great thing those bad time, can give us. And the company was acquired by Apple in 2008, which is like, like the subprime thing, which like the whole economy seemed to be like, the world seemed to be burning up, and we were acquired by Apple, and ride basically the long ride of like how Apple now become like 30x more valuable, and I still have like that's still it can end up to be pretty good. And we are now in the global pandemic of COVID-19. And like, I didn't recognize that like we built like a training app which have that you can do this workout at home. And we did not realize we actually built an app that's like really right for this time, and receive a huge COVID bump of like, we have signed up like, close to 1 million users in the last quarter. And also during this time, I think what I want to say is that like, it really doesn't matter. Like, it's a good time or bad time, because you will see all these cycles. And after you've basically been through it like a couple of times, like all these cycles, sometimes bad times, sometimes good time. But like, if you are, focused on creating, what you want to create with a vision, and this is what draws people to you, is what draws like, capital and people to you. And it honestly doesn't really matter much. And sometimes it actually create opportunities, something that we have even not anticipated, that we don't know, like, wow, COVID-19 hit, then like our users and our revenue jump off the roof, our revenue go off the roof, and we did not expect that. So that was, when there's, bad times, always new opportunities as well. So just look at the bright side, and, also look beyond Hong Kong as well. So I've never created a company just like for a local market. And the opportunities is just everywhere. And just like in the month of April, that Home Court is like ranked number 4 overall app in Thailand. It's like if we do anything in Thailand, it's hard. Just that like we just can the market and can pull you into some places which you have never expected before. And the most important thing is just like start building, and have a vision, and you would get there.
Thank you, David. I cannot agree with you more that whenever there are challenges, there are always opportunities ahead for us to grasp. There's another question for Ada. Thanks so much for the amazing talk. The question is, compare with the current pacemaker, how much money is saved using your mini pacemaker? Also, the diseases you are focusing on are most prevalent in elderly. Since elderly are most at risk of post-surgery complications, have you assessed the surgical risk for implantation in older animals? Ada, please.
Okay, so for the first question, the pacemaker, actually the mini pacemaker is just for demonstration purpose to show that, how small that we can make the things to cause therapeutic actions. I love to think about making a mini pacemaker, but anyhow, the technology already licensed out to startups. They try to do the translational job to make it useful. I'm not interested in that, to be honest. I like research more. So therefore, how much money is saved and all this, I'm not quite sure. So I will let our licensee to answer those questions. But for the diseases that I'm tackling, that seems to be more for the elderly, but it is a correlation that because we get all our organs are not malfunction. So we have certain warranty time for our organs. We try to extend it longer and longer because our night spring, it is getting longer and longer. And therefore, it will have a lot of diseases. So therefore, it is not a surprise that a lot of diseases that correlate with the elderly. So implantation, the reason why we want to make it really small, it is because of the implantation. We want to make minimally invasive implantation. For example, for the pacemaker that we make, when we do the in vivo testing on animal, we use not the open chest kind of surgery to implant them. We have a catheter that is bringing that tiny pacemaker through our blood, through the animal's blood vessel. So we draw a hole in the neck area or the thigh area with the catheter, just deliver the pacemaker inside the heart chamber to do the pacing. So I hope that with this type of miniaturized devices, it will make the implantation much easier. For example, the artificial pancreas that we're talking about, we are trying to implant them, it is subcutaneously underneath the skin, just to provide a limited supply of glucagon and insulin. So with the electronics approach, hopefully it will also make the implantation minimally invasive.
All right, thank you. So the next question is, what is the prospect of engineering career in Hong Kong? Because Ada and David are now in California. Only Ka Leung and myself are in Hong Kong. Because I'm the Dean of Engineering, probably no one will believe in what I said. My answer is obviously a positive one. So I would like to invite Ka Leung to comment a bit on the current prospect of engineering career in Hong Kong.
Well, I speak from my perspective. In particular, on civil engineering, I can see the medium-term prospect as very bright. Because of the population expansion, we have a huge shortage of building flat space, plus the expanding population. So that's why there will be a lot of demands for new flats, new buildings. Then there will be associated demand for the infrastructure. So short term is very bright. In fact, maybe if I speak from my company perspective, you also don't believe me, but in fact, our company, we are very busy preparing for a lot of tendering for buildings and civil engineering in the coming 1 year. So positive.
And I want to add one thing. It is what you are studying. It doesn't mean that you have to do it in your career. engineering is just to provide you with the analytical training, and you can apply your analytical training to any problems that you feel you're passionate about. So don't limit yourself. It is to a very particular narrow box of things that you could do.
This is exactly the next question I like to ask all of you, which is how studying at Hong Kong U Engineering helps develop your career. I think Ada already gave us some of her insight, which is you don't necessarily need to go into the engineering profession, because studying engineering give you probably a broader dimension of what you can do in the long term. How about other two speakers? Do you have any comment on this question? How studying engineering in Hong Kong U, leads you to the current career development?
First of all, I have to be absolutely agree with what Dr. Poon have said, that you have a set of tools that you acquired through studying engineering, in Hong Kong U, and I have to be honest, when I start building companies, and after a short while that my team don't let me write code anymore. They always try to you should have better things to do, but I still have that this is great tool set that I have in my set of tools that I constantly apply to be more rigorous, to be more analytical, to be breaking down problems, and those basically are a set of tools that basically can apply when you're thinking about designing that feature, when you're basically discussing a deal, with a company or with your investor or potential acquirer, that also give you that something engineering give you a lot of patience, because when you're gonna sit there basically work on a very comprehensive problem, break down the problems and solving one by one, right? And just that I cannot just name that how beneficial that training have been. For me as an entrepreneur, that we're solving a wide variety of problems. One day we're really gonna talk to instead of our engineering team and figure out problems. And on other end now I'm sitting with the design team and thinking about things for design. And those tools, those analytical skills is just extremely valuable. I'm not saying that you would also kind of pick up other skills as well as you go, which is also necessary. But I would say that training gave me a lot of great foundation.
All right, thank you. So one last question I'd like to ask you before we end this forum, as time is really tight. The last question is, what are the tips that you would like to offer to our fresh graduates or students who are interested in studying engineering? Any tips you'd like to offer to them?
Maybe I go first.
Sure.
Just follow your passion. Don't think too much. I think we try to optimize our lives too much, optimize every aspect. But I think the most important part is you just have to follow your passion and doing the random walk. And at the end, your path will towards the kind of things that you would like to do from the bottom of your heart. Don't optimize too much.
All right, good. I agree with you.
Wow.
Gala, you want to add something?
Well, Ada, I cannot agree with you more. I actually want to talk about following passion. So if I would like to add, I would say there's a part about acquiring academic or let's just say some professional skill set. But down the road, I believe it's a matter of, let's say, characters. It will be down to trust, respect for people, communication. I think those are also very important in particular when you go further down the road. But really, following your passion, it's a big thing.
Passion, empathy, right? passion and empathy.
Wonderful. David, you want to add a final remark?
Sure. Like, what Ka Leung and Dr. Poon said is absolutely the way to go. And it's always that passion, always that vision that draws, is just a really important step, towards success. And it's just really following your heart. And, I think, you would not regret looking back, because you would regret if you're not following your heart. And you follow your heart, you would not regret. Like, you would accept, you would basically put yourself at ease. All right, this is the thing that we want to go, and would accept whatever happens to it, and then keep going. And at the end, you might be at your destination without we even and also probably enjoy the process. And that just a path of happiness, I would say. Just follow your passion is just the path of happiness. So let's end here then.
All right, wonderful. I was asked to give a 2 minutes concluding remark before we end this section. I have to say thank you to all our alumni and participants in this forum. In that, if you ask me the question of whether engineering is a topic worth a study, my observation is that I think the timing nowadays is perhaps one of the best moment. The reason is that every day we are talking about how we make use of technology to make our world better, or how to save lives, how to bring new technology to make people live a happier life. We have ample opportunities to go deeper into some very exciting projects nowadays. If you have engineering knowledge, basically you don't necessarily need to go into engineering as a profession, but you can make good use of it to help tackle many interesting global challenges, as well as, for example, to become an entrepreneur, to build new products, service, or solutions in order not only to earn a living, but to make your life more satisfied and to make a bigger impact to society. Some of you may be aware that we receive a major gift donation from one of our alumni in the 50s. He donated $120 million to Hong Kong Engineering to build up Innovation Wing Phase 1 and also Innovation Wing Phase 2. Innovation Wing Phase 1 will be open after summer. So all the new students and existing students will be benefiting from it. We are going to have a 2,000 square feet maker lab area, which is one of the largest in Asia, to bring student learning activities, project-based activities into the facility, so that students in different interest group can work together to tackle some global challenges. This is, we believe that this will be an area that we are able to nurture innovation and also to create future leaders into our society. So it's getting late in California now, and I think it is also time for us to go for lunch in Hong Kong. So I don't want to keep you here too long. Thank you very much. Thank you so much for joining this wonderful talk. I hope that we're able to get more of this type of activities on a continuous basis. Stay tuned. Thank you. Good night and have a good time.
You.
Thank you. Bye-bye.
Thanks a lot. Thank you. Bye. Bye-bye.
Bye-bye.